Blockchain 1.0 has as main features the distributed ledger, the cryptographic security, and the immutability. The blockchain is also referred to as a distributed ledger. This is both because a large number of nodes on the blockchain network possess their own copy of the entire ledger and that they are connected to one another. This creates a distributed arrangement of nodes. This is an important design choice because when a block of transactions is ready to be uploaded onto the blockchain, the individual nodes participate in a voting mechanism to decide which node, called the leader, makes the addition. Bitcoin, for example, uses cryptographic proof instead of the trust in the third-party mechanism for two willing parties to execute an online transaction over the internet. Each transaction is protected through a digital signature, sent to the public key of the receiver, and is digitally signed using the private key of the sender. In order to spend money, the owner of the cryptocurrency needs to prove his ownership of the private key. The entity receiving the digital currency then receives the digital signature, which implies ownership of the corresponding private key by using the public key of the sender in the respective transaction. Each transaction is broadcast to every node in the Bitcoin network and is then recorded in a public ledger after verification. Every single transaction needs to be verified for validity before it is recorded in the public ledger. While there are ways to change the blockchain, as in the case of hacks or upgrades, these changes are difficult to implement and require structural modifications rather than changes to the block transactions themselves because of the very same property of immutability. Blockchain 1.0 includes two main concepts. The first is the Byzantine fault tolerance. The second is the public key cryptography. The Byzantine general's problem refers to a hypothetical scenario where consensus must be reached between participants. The problem statement is that a number of generals of the Byzantine army must coordinate their movements on the battlefield. Public key or asymmetric cryptography is a subfield of information theory that underpins much of modern-day computer security. The mathematical underpinning of public key cryptography lies in families of mathematical functions that are injective and irreversible. Elliptical curve cryptography uses a different class of functions that are less computationally intensive than those used in RSA. It has been getting attention from computer security experts as a possible replacement for RSA. Elliptical curve cryptography is the implementation of choice in Bitcoin.